Okay, so I haven't actually made this video in past years, so I thought I'd do that. I noticed a couple people were asking questions specifically about completing the square. So I thought it might be helpful for us to go through just one of each problem so that if you can't remember some little step, maybe you could look back at it, okay? So let's go ahead and see what happens if we just solve a couple of quadratics, okay? So the first thing is what I mentioned in class is the absolute first, the go-to story for quadratics is to try to factor it if you can. Now, my personal preference is what we call guess and check, which really doesn't sound like it's a smart way to go, but honestly, it's the right thing to do to be fast on these problems. The other methods work. They're very reliable. I'm not saying they're bad, but they do slow people down a little bit. So when we start a problem like this, the 6x squared, the first thing that jumps out at me is most likely if it is to be broken down as two pieces, as this product of two binomials, is that one of them is going to be 3x and one of them is going to be 2x. Now, is it entirely possible that it could be a 6x and a 1x? Well, that is a possibility. That's part of the guess and check. It's just like playing chess. You think about which piece would I move, which is the one that is most likely going to yield a good outcome for me. So it could be either one of these. The second thing that I noticed myself is that with this number being a positive, then these two numbers either have to both be positive or they both have to be negative. And you can tell if they were both positive, there would be no way to bring a negative value into the story. So I know that they're both going to be negative. Now, as such, I need a 7 and a 1 because this is a prime number. Now, we don't always get prime numbers. I didn't start here with a prime, but I did give you one here. So I either have to put a 7 here and the 1 here. So keep in mind, if I were to put maybe the 1 here and the 7 here, I have to think, would that yield the answer 23 in the middle? So if I distribute, I've got 6x squared, that looks good. I'd have a negative 3x here and a negative 14. Well, a negative 3 and a negative 14 will not combine like terms to come up with that value. So it looks like I messed up. So maybe I should reverse those. Now, the reality is, you might have just thought about it before you wrote it down and realized to get up to the number 23, I'm going to need a pretty large multiplier. And you can see 21, negative 21, and negative 2, in fact, does make negative 23. I'm not going to need this value because it's actually a theorem in algebra that says when you factor a problem, the solution is unique. There's literally only one solution that is valid every time. So as soon as we have one, there isn't a secondary answer, okay? So keep in mind, we're not done because factoring was the tool. It was not the solution. So we're going to go over here and I'm going to make a list of the answers. And the lowest answer that would make 0 happen would be positive 1/3 and positive 7/2. Now, I'm actually not a super formal person. So if you wanted to say x equals 1/3 or x equals 7/2, I would be good with that as well. It's okay. All right. Now, if you like the diamond method, I will mention it because I didn't do that in class. So I'm going to put that right here. The diamond method works every time. And it actually, believe it or not, has guess and check buried in it. And we'll explain that right here. So you're not avoiding guess and check when you go to the diamond. It's just buried in a spot. So the first thing that happens is we take the product of these two values, and I put it right here. That's 42. I put the bottom number right here, 23. Here comes guess and check. I have to think through all of these numbers that would have a product of 42, like 1 and 42, 2 and 21, 3 and 14, 4 doesn't go in, 5 doesn't go in, 6 goes in, right? I need to go through all of these numbers and I need them somehow to come up with a product of 42, but somehow they have to have a sum of negative 23. And so what I can see is right here, if I made both of these numbers negative, negative 2 and negative 21, they in fact do have that sum of negative 23. So what you were taught to do back in the day is then you would actually make it what they called, oh gosh, what do we call it? Some people call this a modified diamond. There's a whole lot of names for it, but we go ahead and populate these boxes with the components of the quadratic. I put a 6x squared here, that's always A. I put C here, and the B value that we talk about, we broke it up as a -2 and a -21. Now, everybody has their own approach, but I look for greatest common factors. And so, like, for example, when I look at these two, I would notice they both have a 2 in them and they both have an x. And I know that 2x times 3x would in fact be 6x squared. And 2x times -1 would be -2x. 3 times -7 would be -21x. And to check my answer, you can see this product works. And you can see I got exactly the same factors that I had. And it didn't take me a whole lot extra time. It did take some space, but that's okay. So that's solving by factor. Now, a better solution, in my opinion, often is going to be completing the square. This solution will only work if my answers are rational. If my answers are irrational, then this top method is going to fail me. So what we do when we deal with this is I would probably start by going, well, shoot, I don't think this thing factors, but let me double check. Can I come up with a couple of numbers that multiply to -8 and add to -11? 1 and 8 fails, 2 and 4 fails. Those are literally the only two options that I have. I can't make a 1 and an 8 into 11, and I can't make a 2 and a 4 into an 11. So I guess we're going to have to go with one of the other solutions. So my thing is, if they ever hand me a leading coefficient, I divide by that leading coefficient. So here we go. Now we are down to something that has a leading coefficient of 1. That makes life a little bit easier. Now, let's see what we can do. The first thing I personally like to do is I like to open up a little spot. And this spot is just a little visual reminder that I'm going to do something right here to complete this square. So that little green spot, I'm going to add something fairly to both sides to make sure that this problem remains equivalent to the original problem, but is structured better to complete the square. So I'm going to take this portion right here. I'm going to take -11 halves, and I'm going to cut it in half, which is going to give me -11 quarters, right? A half of a half is a quarter. But keep in mind, it's cut in half and squared. So if I squared this number, I would get 121, because 11 times 11, and 16. And keep in mind, you're squaring it, so you will always yield a positive answer. So I got 121/16 that I'm going to add to both sides. Now, I purposely made this problem kind of hard, not exactly pretty, but I have created this perfect square. This number right here will always be that number when you cut it in half. That's just how it works. Now, over here, I need to put these two things together. And I could either do it in my head and think about this as 32/16, and that works awesome. I love that. And we could put 32 together with this and get 153/16. And that's a great answer. But if you are not sure that you're doing that, just the fractions right, you could use a calculator and say, let's say 2 plus 121/16, and hit math, enter twice, and you're going to see that it confirms my answer of 153/16. Please try to do it in your head before you just chicken out and use the calculator, because it's nice to make sure that you know how to do your basics. Okay, we're almost done with the problem, because I'm going to take the square root of both sides. Don't forget, every time you take the square root of both sides, you always get a plus or minus. The square root of 153 is not a pretty answer. I'm not going to be able to do much with that. The square root of 16, of course, is 4. And so that means the only thing left to do is to add that 11 quarters to the other side. So I'm going to have 11/4 plus or minus the square root of 153 quarters. And that's pretty much my final answer, and it looks great, okay? Now, I am going to do something with that in a minute, but I'm going to do that on the next one down, okay? So you're going to see that I'm going to show you the same problem, but let's look at this through the lens of the quadratic formula. And some people really like the quadratic formula, but we have to be very, very careful, because this problem has so many pieces of order of operations that people often make mistakes in, okay? So in this particular problem, don't forget the x equals. A lot of people forget that. You're not just saying a number, it's that you're finding the value of x, that solution. So we start with the opposite of b. We take b right here and we square it. Now keep in mind, everybody should know that if you square that number, you're going to get a positive value. Your calculator, if you said, hey, calculator, what's negative 11 squared? You're going to notice it says negative 121. It's because the reality is you took negative 11 and squared it, because the calculator will do what you asked. And right here, it squared the 11 and then attached the negative afterwards because of order of operations. But we didn't need a calculator anyway, so why would we do that? But I watch students do it all the time. Now I'm going to have negative 4, and I'm going to take the product of A and C right here, which is negative 8. I'm just watching my pluses and minuses very, very carefully. And what we should end up with is the same answer we got before. 121 plus 32 is 153. So you can see that this validates the solution I did using completing the square. The only thing that I didn't have in that first part is that sometimes when we get to this root, we can simplify it a little bit. And so we could go, is there any perfect squares that are sitting inside of 153? Can I simplify that? Well, let's think through it. Would 4 go into it? No, because 4, it has to end in either 2 or 4. It has to be an even value. Ooh, does 9 go in? Well, as it turns out, I actually just made this problem up at random, and I didn't expect it to simplify, but it does. 1 plus 5 plus 3 is 9. Since the digits add up to a multiple of 9, it's 9. That means 9 is going to divide into this thing perfectly. So if I took 153 and divided it by 9, I get the number 17. So what I could do is I could think of this, instead of 153, I could think about it as the product of 9 and 17. So the best answer is 11 plus and minus 3 roots of 17 all over 4 is x. Okay? So sometimes we can simplify, and it's always important in a math class to stop and think, have I done everything that I can do to come up with the most simple answer that I possibly can? Okay, I will see you back in class soon. Goodbye.